Welcome back, everyone. So today in this video, we're going to be looking at parallel circuits. All right. So this is an example of a parallel circuit. Basically what happens is as the current leaves the battery, or is pushed along by the battery, it has multiple paths that the current can take. Right? So it's different than a series circuit where it's all just one continuous path. Here in this case, current gets to here, well, some can go this way, some can go this way. Gets to here, some can go this way, some can go this way. Okay, so that's the basic premise of a parallel circuit. Right, so let's take a look at how the overall values of the circuit are affected when connecting resistors in parallel. So what does that mean? Well, I'm going to look at how is the voltage across each resistor affected. How is the current across each resistor affected? Again, all compared to its total value. And how is the overall resistance of a parallel circuit affected? Right? Well, let's first start with the voltage, the electric potential difference. Okay, think back to Kirchhoff's loop rule. Okay, Kirchhoff's loop rule says that in any closed loop, the voltage must drop to zero as it makes its way around. Okay, so if you look here, R1 makes its own closed loop, right? Current can just keep going around in this loop over and over and over again. That's a closed loop. R2 can make its own closed loop. R3 can make its own closed loop. Right? So what does that mean? Well, that means the voltage across each resistor is exactly equal to the voltage of the source. Well, let me be a little bit more clear. The voltage of each branch is equal to the voltage of the source. Right? So I'm going to write it like this. V total equals V1 equals V2 equals V3 equals dot dot dot. Okay? Now, let's take a look at the current in a parallel circuit. Well, in order to fully understand your current in a parallel circuit, let's discuss another one of Kirchhoff's rules. This is Kirchhoff's junction rule. What Kirchhoff's junction rule says is that as the current enters a junction, right? So you have some current entering the junction right there. The amount entering is exactly equal to the amount leaving. So this amount plus this amount equals this amount. Again, over here, there's current entering over here. The amount here plus the amount here equals that. Coming back around, as the current's coming back, right? This plus this will equal this. And this plus this will equal that. Right? So in other words, the total current is equal to the current in the first branch plus the current in the second branch plus the current in the third branch, and so on and so forth, depending on how many resistors you have in the circuit. All right? Awesome. So now what I'm going to do is I'm going to take what I know about the voltage in a parallel circuit and the current in a parallel circuit, and I'm going to use them and Ohm's law to help me figure out how resistance is affected by adding resistors in parallel. Okay, so I'm going to use this version of Ohm's law, I equals V over R. Right? We've used it before as V equals IR, or R equals V over I. But I'm going to use I equals V over R simply because I know that the i's all add up, so I'm not going to end up with just 1 equals 1 equals 1 equals 1. So I'm going to rewrite the current formula, but with V's and R's. Okay, so it's V total over R total equals V1 over R1 plus V2 over R2 plus V3 over R3 plus, dot, 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 how many ever you've got. Well, we saw earlier that the voltage across each branch will be equal, so we can cancel all those out, and we're left with 1 over R total equals 1 over R1 plus 1 over R2 plus 1 over R3 plus dot, dot, dot. Okay? There you go. There's how you find the total resistance, or the equivalent resistance, in a parallel circuit. Okay? The way this works is the more resistors you add in parallel, the lower your resistance overall will get. The lower your resistance, the more current you have. Okay? What's a neat consequence of parallel circuits, in that each kind of branch is its own loop, is that one branch can go out. It can, the bulb can burn out or something, and the other bulbs will stay lit. Right? It's like Christmas lights, for example. Right? One bulb goes out, many of them still stay on. Right? It used to be one goes out, they all go out. That's a series circuit. But with parallel circuits, you have one bulb out, the rest pretty much stay on. So yeah, I find that kind of neat. Anyways, that's all I've got for basic parallel circuit type stuff. In another video, we're going to talk about how we can solve problems with parallel circuits. How can we solve things about the total current, or current in a branch, or the voltage across a branch, the total resistance, stuff like that. So keep an eye out for that one. But until next time, I'll see you later.